Welcome to qnawire.
In this problem, they tell us that doubling of the torque produces a greater angular acceleration. Okay, yeah. And which of the following would do this, assuming the tension in the rope doesn't change? Okay. So again, I guess we have some, this table, there's some rope here, and we're pulling on it, and it's basically unspooling, and it's causing the a torque to cause that angular acceleration. So the really simple answer is, well, that torque is T, the tension in the cord, at the cable, or the rope, times R, the radius of the platform, the disc. So angular acceleration is TR over J. So naively, if we doubled R, we would then double alpha. So our naive answer would be B. And in fact, that's the only answer that they give that makes any sense at all. But I think it's really just a bad problem. Obviously, if R doubles, then alpha is going to double. You can see that. But that's assuming J doesn't change. Well, if you double the radius of the platform, you'd expect J to change, and in effect, in a way that this goes up. So let's see what actually happens here if we were to double the radius. So J naught depends on R also, right? And so if it's a uniform disk, it's 1/2 m R squared. But m is the mass, right? So that is the density times the volume of that platform. So J naught, in fact, looks like pi over 2, the density times the thickness times r to the 4th. So J is going to scale like r to the 4th if we keep the same material. So if we just make this platform out of a bigger material, then, or out of the same material, then we're going to get a big increase in the mass moment for the platform. Now, if alpha initially is TR all over, pi halves r rho, pi over 2 rho h r to the 4th plus the mass moment of the person on it. Now, after we change things, T is going to stay the same. J1 is going to stay the same. The density, we'll assume, stays the same. So we're making a platform out of the same material, and we're making it the same thickness. Now we get R prime here and R prime to the 4th here. So that's what's changing. Now R prime is 2R, so we can substitute that in. So we get 2T times R all over 8 pi rho h r to the 4th plus J1. Okay, so what we can see here is clearly doubling the radius causes the mass moment to go up by a factor of 16, so 2 to the 4th, which would completely obliterate the extra torque that we get here, right? So that goes up by a factor of 16. So now, instead of 1.5, it is now 24. And you could say, well, maybe this is negligible compared to that. Well, we already figured out that it wasn't, because initially it was 1.5 compared to 6, which is that's not a significant. You can't neglect that with respect to that. Now this is actually much bigger. This is it's 8 times? No, 4 times what this is. So there's no way that we can say that this is negligible compared to that. So if we actually plug in things, we can see that tau prime goes to 2 tau, J naught prime goes to 16 J naught, and so if we plug both those in, we get that this is initial torque was 2.5, so this becomes 5, this becomes 24, and this is 6. So we get that our new angular acceleration is 1/6 radians per second squared, or basically half of what it used to be. So it's not double, it's half. But there's no other answer that makes any sense in this problem. So what we'd have to do, if this were going to work, we'd have to reduce the thickness of this platform by a factor of 16, so that we'd have an H prime here, right here, sorry, H prime here, and then H prime would have to be H over 16, and so that then, the 16 from 2 to the 4th and the 1 over 16 from here cancels out, so that J naught stays the same. So if we could somehow make the platform 1/16 the thickness and double its radius, then this would work. But in all practical purposes, doubling the radius is not going to change, is going to actually reduce the angular acceleration, unless somehow we have some arm out here or something. But then how to, and it's really hard to unspool from an arm. So again, it's just, I think, just a bad problem. None of the other answers make any sense. You can plug in, all the different ones if R was increased or decreased by different factors, and none of them get us to doubling the angular acceleration.